origin of the history of mathematics can be dated long back to the early man. Neanderthal man commonly used mathematics for various of his daily activities. One of the most important was counting, which he used to count the number of animals he could attack. In the Greek system, numbers were often represented by strokes, but the Romans had a more efficient system. They used separate symbols for 1, 5, 10, 50, 100 and so on, and thus representation of large numbers became much easier. However, the most practical system was the Indo-Arabic system. It involved use of digits from 1 to 9 and a new concept, the concept of zero. We shall now see how geometry has evolved over the ages and the various mathematicians who have contributed towards its development.
Euclid of Alexandria is sometimes referred to as the father of geometry. Much of his education was thought to have come from the knowledge of Plato's students in Athens, Greece. Little is known about Euclid's personal life outside of his written work, the most influential of which is titled Elements. Elements expanded on many earlier mathematical writings, especially from those of the Platonian Academy, founded in 387 BC. Though many of its theories are borrowed from the works of earlier mathematicians, Elements transformed the way mathematics was perceived amongst scientists. Prior to the time of Elements' writing in around 300 BC, mathematics dealt with only hard problems, formulas, and their solutions. Elements revealed the philosophy behind mathematics, which could then be studied as an intellectual occupation. Contained within the pages of Elements are a system of proofs that are still today the foundation of mathematics, some 23 centuries later. The greatest aspect of Euclid's work was that it categorized known mathematical method, thus creating a foundation that could easily be referenced and examined. Elements gave us a window into geometry and number theory that greatly influenced the work of future mathematicians, including Johannes Kepler and Sir Isaac Newton.
Pythagoras is most famous for proving the Pythagorean theorem, also known as a squared plus b squared equals c squared, one where two of the sides come together to form a right angle. In our example, side A is 4 units long. This means a squared will be equal to 16 square units. Next, we'll draw side B. This side will be 3 units long, making b squared equal to... Now that we know that a squared equals 16 and b squared equals 9, we can add them together and find that in this example, c squared is equal to 25 square units. Here, we can take the square root of 25 and find that side C, also known as the hypotenuse, is equal to 5.
The ancient Egyptians and Babylonians had known of theorems on the ratios of the sides of similar triangles for many centuries, but pre-Hellenic societies lacked the concept of an angle measure, and consequently the sides of triangles were studied. The Egyptians used trigonometry extensively in the construction of their pyramids. The next significant developments of trigonometry were in India. Influential works from the 4th, 5th century, known as the Siddhantas, defined the sine as the relationship between the half angle and half a chord. Soon afterwards, another Indian mathematician and astronomer, Aryabhatta, collected and expanded upon the developments of the Siddhantas in an important work called the Aryabhatiya. However, it was Leonhard Euler who modernized trigonometry and introduced the trigonometric functions, now regarded systematically as ratios that are dimensionless quantities. He also proposed the Euler's formula to find out the sine of an angle x, given by sin x equal to e power ix minus e power minus ix divided by 2I.
The calculus, one of the most basic and fundamental tools of modern mathematics. Two men can rightly claim to have invented it: Isaac Newton and Gottfried Wilhelm Leibniz. Newton actually discovered his calculus first, in 1665 or 1666. Leibniz made his own independent discovery of it some 10 years later. However, neither man saw fit to publish what they'd found for some years after that. What's really fascinating is that the original writings recording the discoveries of both of these men are preserved. In the University Library of Cambridge, we have the notebooks that Newton kept between 1665 and 1667. And in Hanover, Leibniz's notes from 1676 are preserved as well. They provide a fascinating glimpse into the process of mathematical discovery that both of these men used, and it's really exciting to be able to study them. We start our story with Newton. Newton was a student at Trinity College, Cambridge, and in January 1665 he took his degree and became Bachelor of Arts. There then followed 2 years of intense work in which many of Newton's basic ideas on the calculus, as well as optics and gravitation, were formed. We shall restrict ourselves to his mathematics. In May 1665, Newton was working in Cambridge. He was rapidly mastering and improving on the methods of Descartes and Hooder for finding tangents. The contemporary way of finding a tangent to a polynomial curve, that is, a curve with a polynomial equation, was as follows. To find the tangent to this curve at the point P, look at circles with centers on the x-axis passing through P. Most circles will cross the curve at P and recross it at another point, but one circle will just touch the curve at P. The line from the center of this circle to P is called a normal, and the line at right angles to this normal through P is the tangent to both the circle and the curve. Hooder, who was a smart mathematician, had developed a cunning way of finding the center of this circle, which used the following trick invented by Fermat. In general, a circle cuts the curve in 2 places. Suppose this distance is O. Now find an expression for the distance, d, of the center of the circle from some convenient reference point in terms of O.
Set theory is the branch of mathematics that studies sets, which are collections of objects. Although any type of object can be collected into a set, set theory is applied most often to objects that are relevant to mathematics. The modern study of set theory was initiated by George Cantor and Richard Dedekind. Set theory is commonly employed as a foundation system for mathematics, particularly in the form of Zermelo-Fraenkel set theory with axiom of choice, proposed mainly by Zermelo-Fraenkel. Probability theory is the branch of mathematics concerned with probability, the analysis of random phenomena. The central objects of probability are random variables, stochastic processes, and events. Mathematical abstractions of non-deterministic events or measured quantities that may be in single occurrences or multiple. Andrei Kolmogorov, Perry D. Fermat, and Christian Huygens were the main mathematicians who contributed to the development of the probability theory.